Okay, in this problem, the light bulb in figure is rated 120 volts with 0.75 ampere. Calculate volts to make the light bulb operate at the rated conditions. So, what we are going to find is the volt source. Okay, we are just to input our givens. Okay, so in our light bulb, we have 120 volts with 0.75 ampere. Okay, what we are going to find here more in our bulb is the resistance in terms of ohms, and here also in the side in 80 ohms we are to find the current here. Okay, and the volts here is equivalent to 120 volts. Remember that in parallel conditions we have the same volts. Okay, and also in parallel conditions we are just to add our currents, and in adding our resistance, okay, this is our formula: 1 over resistance 1 plus 1 over resistance 2 plus 1 over resistance 3, and so on and so on. Okay, so first we must focus on this loop. Solving for the current in 80 ohms, we have the formula V is equal to IR. Given the volts, we are just to substitute the givens. We have 120 is equal to I times our resistance 80 ohms. Okay, so we can now compute using our calculator. Here's our calculator. We have 120 is equal to I represented by X. Okay, 120 is equal to I represented by X times 80. We have 1.5 ampere. Okay, 1.5 ampere. We're just to write it near this 80 resistance. Okay, 1.5 ampere. Also, we are to compute for the resistance here in our bulb given the volts and the current. Okay, the same formula, V is equal to I times R. We have our volts, 120 is equal to I times our resistance, the unknown. Okay, we already have our current, by the way, 0.75 times R. Okay, so our resistance here is, using our calculator again, we have 120 is equal to 0.75 times R, which is equivalent to 160. Okay, we have 160 ohms. Okay, as what I have said, in computing for our currents or I in parallel conditions, we are just to add these things. Okay, so we have here 0.75 in our bulb, and in our given 80 ohm resistance we have 1.5. So we have a total current of 0.75 plus 1.5. So our current is 2.25 ampere. Okay, so next we will move on in computing for our resistance. In parallel conditions, we have this formula as we have said a while back. So we have here in our bulb, we have a resistance of 160 ohms here. Okay, So computing for this is equal to 1 over 1 over 160 plus 1 over the resistance given here, the 80 ohms, over 80. So we have our resistance is equal to, using our calculator again, we have 1 over 160 plus 1 over 80. We have 53.33 ohms. Okay, so these are the givens now. These are the numbers now that we are to consider in solving our volt source. So given here our new current and new resistance. We have IR. Okay, so in this condition, okay, para hindi ka malito, we are just to copy these things in the figure. Okay, copy. We have the current and we have the resistance here. Okay, now it is a different condition. Now if we are going to make a loop here now, okay, these are now connected in series condition. Okay, so the relationship of this one, okay, they are now connected in series conditions, and in series conditions we have the same, what should I say, the same current or the same the same I, and we are just to add our resistance. Okay, the formula now in series conditions, we are just to write this here. Resistance is equal to resistance 1 plus resistance 2, and in current we have this same. Okay, that is in series condition. Okay, first we are just to compute the volts here because we are trying to find the final or the volt source. Okay, we are to expose everything here in terms of volts. So given the I, as what we have said a while back, that in series conditions we have the same current, so we have V is equal to I R. So what is the volts here? We are to find the volts. Okay, we have the I 2.25 plus at times the resistance given 40. So we have our volts using our calculator. 2.25 times 40 is equal to 90 volts. So we have 90 volts here in the given 40 ohm resistance. Okay, we are just to write it near the given. Okay, we have 90 volts. Okay, considering the loop, the total must be equal to 0. The summation of all volts is equal to 0, or the summation of all power is equal to 0. Okay, so we have here volt source is equal to the volts in our 40 ohm resistance that is given, 90 volts, and the volts here in our bulb, which is 120 plus 120 volts. So our final answer now, or the volt source now, is equivalent to 210 volts. And that's for it for this problem. I hope you understand.